So in this video, I'm going to be starting probably a little brief series on just putting together your own ESP32 board. And there are a few reasons you might want to do this, but the first thing that I would say is you really want to make sure that you want to do that and that it's necessary before you jump off in designing your own PCB. Now, you might want to do it for fun, and that's totally cool, right? If you just want to do it, that's great. But if you're doing it for a more focused reason, you really want to make sure, do I really need to do my own PCB, or will a regular dev board, plus some extra wiring accomplish the goal? Because typically using a dev board is going to be way easier, way faster, and way cheaper if you're doing like a 1 or a 2 off project where you don't actually need a whole bunch of something. As we get into this, also understand that I'm not a professional, and so I'm going to be sharing some stuff from the way I approach it, but I'm not an electrical engineer or, again, any sort of a person who has a professional experience in this area. This is just stuff I've learned from messing with it and from screwing up, and I figure I'd save you some time and money if I can. So, these are kind of the main things you need to start off thinking about. What are your goals? What sort of peripherals do you need? Do you need displays? Do you need special sensors? What sort of protocols and buses do all these things need? Do you need USB connectors? Are you going to be using like DuPont pin headers? Are you going to be using JST connectors or something specialized like a FPC or something like that? That can really complicate things. And on top of this, the more stuff you add, you have to start thinking about what sort of calculations are going to be needed to run all this stuff, and what sort of accessory hardware do you need to run all these sensors, like ADCs or mux expanders or stuff like that, right? Those are all things that you need to think about right up front, because you're going to be driving all this stuff with your ESP32. You got to make sure that you pick the right ESP32 that can handle all this. And you have to start thinking about cost and complexity with all these connectors needing their own space and needing a bunch of extra resistors and capacitors and traces that fit into this board. There's a lot that goes in that. So again, right up front, you need to really narrow down what is it that you really need and what are the specific sensors that you're going to be using. Again, not just are you using a display, but what display from what vendor are you going to be using? What sensors? What exact model are you going to be using? What actual package configuration of those chips are you going to be using? What specific connectors, right? What specific communication protocols? You really have to think about all that. And if you're going to be doing a lot of like signal processing and stuff like that, you have to take that into consideration too. Also, something I haven't even laid out, assuming that you're doing an ESP32, I would guess that you need Wi-Fi and Bluetooth, because if you don't actually need Wi-Fi and Bluetooth, or Thread or something else, maybe you don't need to use an ESP32 at all. Like maybe an STM32 part would do, because STM32 parts are also really good. They're supported in Arduino. They're very powerful, and they might be cheaper depending on what you need. It's just thinking about these things before you get going. That's very important. So in the next step, once you've kind of documented, here's all the stuff I'm trying to do with this project, and you've really thought through, what do I actually need this thing to do, right? What sensors, what displays, battery connections, stuff like that. Well, next up, you need to think about what module, what ESP32 specific device is going to be the best fit for your project. Because yeah, we can shove an ESP32 S3 at everything. They're just going to be a little bigger. They're going to take up more space. They're going to be a little bit more expensive, right? And there are some other more specialized ESP32 chips, but you want to think about these things, because you don't want to start designing around a chip and then run into problems. Okay, so what kind of things am I talking about here? Well, different packages of ESP32s have different numbers of pins available to actually do stuff. And the more stuff you're doing with your device, you can easily start running out of pins if you're trying to use an ESP32C3 Mini or something, because there's not a ton of pins on one of those. And so that's one of the things you need to start thinking about. And then, like, ESP32s are known for not having the world's best ADCs, and if you're using things like thermistors or something else that needs an ADC conversion, you have to start thinking about, I mean, how much accuracy do you really need? Because if you can get by with the onboard ADC, that's going to be a lot cheaper and simpler than trying to build in an external ADC device, hooking it up and getting all of its power and filtering and everything that that thing needs, right? So that's a big question. Then, if you do run out of pins, because again, no matter what ESP32 module you're using, if you start using really wide display buses with parallel interfaces, you can still run out of pins for those things. And so thinking about, do you need a GPIO expander or something like that? That's another question you got to answer before you start really designing stuff. And then lastly, how intensive of calculations are you really going to be doing? Do you need a dual core? Can you get by with a single core? How much RAM do you need? Because ESP32s come with a lot of different variables as far as how much RAM they have on the device. And I've found that you often don't need a crazy amount of processing power or RAM for most simple devices that you're going to be building. So it's probably a good time to start looking at the actual ESP32 modules that are available to get a sense of what you might be thinking of as far as the trade-offs of one versus another. Now, in this, let me point out that I am going to be showing you modules, and if you're going to be rolling your own device, using a module is probably a little bit better than actually using an ESP32 bare chip, because the modules already come with RF certification and stuff like that, and it's just going to make everything a lot simpler because it's already got all the RAM and stuff on board. Whereas if you're trying to use a bare chip, that's just creating a lot of problems, especially, frankly, if you're watching this video, that means you probably don't really know what you're doing that well. And yeah, using a module is going to be way simpler. So what are the different modules that Espressif offers in the ESP32 line? So at the top end is the S series, and so these are going to be dual core processors that run pretty fast, 240 megahertz. They're going to have usually upper levels of RAM available. They're going to have more pins. They're also going to be physically larger modules. So if we look at this, you can start to understand the ESP32 series by their naming conventions. You have the ESP32, that's the basic series, and then the S3. And the S3, again, is kind of the top-end Wi-Fi model. So within these, you'll see some different configurations. So you can see the W room, and I don't know if there's a special pronunciation for that. I'm sure somebody will tell me. But the W room 1, W room 2, and if you look at these, they're very, very similar packages. They both have onboard antennas. And then you've got the mini line, okay? And so the mini line is going to be smaller, and with that, you would think it would have less pins, but you got to be careful when you start looking at the pins. The pins they advertise does not necessarily mean that's going to be the number of pins available. So you really need to look through the data sheets on these things to find out how much is going to be available to use. So here we are, and we're looking at that S3 mini module, and I just wanted to drive home, just because it says it's got 65 pins, that's the actual number of pins on the module. That's not the number of available pins for GPIO use. If you actually look, a lot of the pins are all along the back and they're ground pins, and at each corner it's also got ground pins. So it turns out, if you actually look at this thing, there might be, I think, maybe 1 or 2 more pins compared to the regular module, but there's really not that many. They're basically the same thing. And so here's the regular module, and what you can see, the reason why they say it has fewer pins is it doesn't have the ground pins at each corner, and it doesn't have the big row of ground pins at the back. So I wish they would advertise them based on the available GPIO pins, or whatever pins you've got minus the grounds, but look, that's the way they do it. You know, you got to pay attention to that with their advertising, so don't fall into that trap. Now, in addition, you've got the 1U units, and these are without an onboard antenna, and you'll see a little port on those, and that's for an external antenna. And so if you're familiar with the Xijiao series, where they have the little plug-in antenna, that's what these are basically. They're a little place where you can plug in an extension Wi-Fi antenna to get them outside of an enclosure, or to give you more specialized antennas if you need that. Again, depending on what you're doing, the ones with the onboard antenna to me are usually simpler to work with. because you don't have to also buy an extra antenna and solve all that. Now, you can get a lot of antennas for these. I'm not going to get into that part of the design, but just know that that's one of the basic trade-offs that you've got when picking a module. Now, on top of that is also, you'll see different amounts of flash and RAM available on these. Whenever you actually go shopping at your vendor to see what they've got available, just keep in mind they may not have every type of configuration available, so that may cause you some trade-offs in your design based on what you can actually buy. But generally speaking, the more RAM, the more flash you want, the more expensive it's going to be. So if you understand basically the way the S3 model line works, basically your choices are, do you want an onboard antenna or an antenna connector? How much RAM and stuff do you want? Do you want a mini package, which is a little smaller, or is a full-size package good enough? Then as we go through the other series, they all kind of offer the same thing. Espressif is pretty consistent about that all the lines kind of work like that. So for instance, if we go to the S2 line, the biggest difference here is that the S2 line only has 1 core instead of 2 core compared to the S3. So you'll see it still goes up to 240 megahertz, so it's a very fast single core ESP32. But if you look through it, you'll see they have the S2 Mini and then the S2 Solo. And what's the difference? Well, the Solo is the bigger form factor, and then they have the Mini, and then they have the variations onboard antenna versus the IPEX antenna connector. And that's kind of consistent, like I said. Beyond that, then you've got choices about RAM and all that other stuff. So on this, also be careful when you're looking through all these chips. I would not grab one of the ones that's marked not recommended for new designs, because sometimes if you're doing prototyping, you might not be able to get that chip again on the next revision. And so that's why you do probably want to go with a current recommended design. Now, as far as between the S2 and S3, again, it's how many cores do you want? The S3 is a dual core, the S2 is a single core. To me, unless there's something else about all the stuff that it offers that you really need, I would probably skip the S2 series and go to a C3 instead if I was going to do a single core. But that's just me. They're just a lot cheaper in general. So let's go look at the C series. And so there's some new stuff out there like the C6, but frankly, unless you need this IEEE 802.15.4. I think this is Zigbee and Thread. So if you want to do a Zigbee design, you need to use the C6. And I think maybe the C5 also has Zigbee. But they've got some new lines that are out there that, again, personally, I wouldn't necessarily recommend unless you specifically need that Zigbee protocol. Because again, you are going to look at different costs with these things. But the C series in general has a single core, and it's a different core kind of architecture in that it's a RISC-V or RISC-V architecture, and it only goes up to 160 megahertz. Now, it's still plenty fast, and most of the things with single core that you're doing, you can get done at 160 megahertz compared to 240. If you really need it, you'll know. But again, typically, if I'm going to use a single core, I'm going to be using a C series and not an S series. I would pretty much only go for an S3, and that's if I really thought I needed dual core. And sometimes you really do need 2 cores simply because it reduces the amount of blocking that processes can't exactly block each other. Also, I believe the way ESP32s are basically configured, one of the cores mostly handles all the BLE, the wireless stuff. And that can be very handy because sometimes those can really block other processes depending on what it's doing over the wireless communications. So on down the line, like I said, I'm not going to spend a ton of time on the rest of these because again, they get pretty specialized. Like the C6 has your Zigbee. C61, I don't even know if you can find these yet. I haven't really seen them out there. It's an ultra low power model. And again, I have not looked into a lot of these in detail because they've really fractured their lineup and created a lot of different stuff these days. The C5, like I said, this is similar to the C6 in that it has a Zigbee. The C5, I believe, is the lower power version. And you'll see again, they've got full size. They've got the mini, and then you've got the onboard antenna or not. Now, the C3 series is kind of what I think is the bread and butter. If you want a single core, the C3 is typically going to be the cheapest model. It still goes up to 160 megahertz. It's got the same RISC-V processor. It only does Wi-Fi and BLE. right? So you're not going to get Zigbee with it. But again, if you're doing most stuff with Wi-Fi and Bluetooth, this is probably the cheapest model. And so again, to me, if you're doing single core, this is where I'm going to go. They have mini and full size models. And again, they have onboard antennas or antenna connectors. Now, you got to pay attention. Once again, they say 53 pins on the mini. There aren't. The C3 models do not have a ton of pins, but if you're doing a very specific focused design, the C3, again, will get the job done as long as you don't need a whole bunch of stuff at once. Now, below this, you start getting into other stuff that, again, is pretty specialized, and you won't really see it out there that much yet because it's all pretty new. The C2 is kind of, I believe, a very low performance model. It only goes up to 120 megahertz. I don't know. I think it has a slightly lower pin count. And I believe the C2 and the C3 are meant to be kind of the replacement of the older versions of the small low power ESP. I forget what was it, the 8266 series, right? Now below that, they list the H series. Now this one does not have Wi-Fi, and it's kind of a newer one, again, that I haven't really seen out there that much. So again, you can look into that a little bit more. Then they have the old ESP32 series. Most of these aren't really recommended for newer designs, and they're getting a little harder to find. They also aren't that much cheaper in my experience. Whenever I've looked at them on suppliers, they're not that much cheaper than like the S3 models. They're good performers, but again, they're just older designs. And so they're based on an older Extensa core. So the newer ESP32S series is based on the LX7. These are the LX6. And again, you know, that's the old models. So if you've got the old dev boards, they probably had these on them. And then finally, you got the ESP8266. This is the really old single core models. These were the really cheap ones. You find them a lot. Wi-Fi switches and stuff that are, you know, been around for a few years. They were often used in these. So like, you know, I've hacked some Wi-Fi switches and found these inside and was able to put ESP Home on those switches because they were using these ESP8266 processors. They don't have a ton of processing power, but they're not shabby. They just, you know, they're old. And so again, if you were thinking about doing this, I would probably go to a ESP32C3. Okay, so at that point, you should basically have, hey, here are all the peripherals I want. You know, narrow it down to here is the specific ESP module that I'm going to be using. And again, you need to figure out exactly which one that you want to use, you know, what variation and all that, how much RAM and everything. Well, then we move to step 3. And at this point, you want to start thinking about how much power is all this stuff going to need. Right? So you've got these peripherals that need power. You've got your ESP32 that needs power. And depending on, are you using, you know, Wi-Fi a lot and stuff like that, those ESP32 modules can pull quite a bit more power when you're using wireless than whenever they're just doing processing. And in all of that, right, you develop a power budget. And so, you know, step 1, how much power do you think your device needs? I can tell you that some of the ESP32s, whenever they're pushing Wi-Fi out there, they can get, you know, 300 milliamps plus sometimes. And on top of everything else that you're doing, right? If you're using big displays, if you're using really fast ADCs, sometimes those can take a little bit more power. All your voltage divider stuff, if you're using thermistors or if you're using any sort of voltage dividing for sensing and stuff, those typically burn a little extra power. Any pull up and pull down resistors, you got to be careful because those can use power depending on what values of resistors you use. So how much power, and then where is the power going to be from? Are you going to be powering via USB? Is it going to be coming from a different power supply? Are you going to be using a battery? What sort of voltage regulators are you going to need? Because voltage regulators will be necessary from your power source unless your power source is 3.3 volts. ESP32s need 3.3 volts. Your peripherals might need a different voltage, and so you're going to have to start thinking about, okay, if I'm using USB, that's going to be a 5 volt in. You're definitely going to need a voltage regulator to drop that down to 3.3 for the MCU. Do you need other voltages available on the board? Right? If you're coming from a battery, if you're using a LiPo battery, those can be anywhere from like 4.2 when they're fully charged and down below 3.5 if you pull them down really hard when they're losing their charge. So if you're using a battery, you're still going to need a step down voltage regulator. You're also then going to need to handle charging. Is the battery going to be disconnected for charging, or will you need charging on your circuit? Because that's going to be extra components for battery management. And then you want to think about connectors, right? Probably you're going to want to go with a USB connector for programming and power delivery, because when it's plugged in, you don't also want to have to be delivering power from somewhere else while you're programming it. Connectors, you're going to need a USB connector. What kind of connector for that? And then if you're going to use a battery, are you going to be hardwiring that thing? Or are you going to need a connector for that? Or if you're using external power sources, all that stuff, right? You're going to need to plan that out and think through it, because voltage regulators come in a lot of different varieties, and they have to be able to handle the amount of current that you're going to be pulling through them, and they need to be efficient if you're going to be using stuff on battery, because some voltage regulators, they're not super efficient, and some are really efficient, but the ones that are really efficient, often, they cost more. So these are all the things you're going to have to balance too. So the next thing I would probably start thinking of is, what kind of special constraints are there in your design? Does it have to be as small as possible, or is space really kind of unrestricted, or do you have to fit it inside of something else that's already kind of pre-made? So I ran into this with my scale design as I'm trying to cram this thing into somebody else's, housing. So I ran into things like, hey, I have to put the display here because that has to fit in this pre-existing envelope. Well, that means that the ESP32 can't be there, and there's only a few other places where it would fit. And then that that means the USB port can only be on a couple of edges, and is there enough room for that? And so size, right? How tiny does it have to be? And then layout can also be an issue. So you want to start thinking about, if you're freeform, this is not a huge concern because you can design around anything. But I will point out that, while we're here with ESP32s, especially if they have the onboard antenna, you can't put that antenna around other stuff. You can't put things on the other side of the PCB. That antenna needs to have a lot of space around it, because you will get interference in the RF signals. So if I pull up this module again, you'll see this big keep out zone for that onboard antenna. And the best design, like what they recommend, is actually having this keep out zone hanging off the PCB. So if you actually look in their design guidelines, you'll see, they kind of recommend that these things be hanging off the board. And if you have to put them within certain envelopes, there's a, minimum that anything should be around it. It's not uncommon for PCBs to have ground planes. And if you put a ground plane underneath the antenna, it will basically block the signal from one side, and that can cause a lot of problems. So they have some things that you got to think about as far as packaging and where can this be, because if your antenna is hanging off on one side of the PCB, that means this cannot be the side of your enclosure. Your enclosure is going to have to be a little further to hold the antenna. And then that kind of limits, well, if that thing's sticking out, you can't really have an USB port right beside it, because then the USB port won't be able to reach the edge of the enclosure very well. And so that's things to think about, right? Is your enclosure a constraint? Is your layout a constraint somehow, right? Do I need plugs in an exact orientation? Because that's just part of the planning process. Okay, and then the last thing to think about is, where are you going to get your parts and where are you going to get this thing made? So certain supply houses will kind of drive what parts you use based on what they have easily available. If you use somebody like JLC PCB, you can look through their online parts, and what you'll find is some parts are called basic parts. Those are much cheaper than the extended parts. Now, most of your fancy stuff, the ESP32 itself, ADCs, a lot of stuff is going to be extended parts, and they're just going to have some extra charges to them. But on top of that, like connectors and things like that, there might be cheaper versions of them out there. And so that's where you got to start thinking about what supplier you're going to use to figure out what stock they have. Can they get you the parts you need? Or do you need to work around what they have? Because there can be some substitutes that you do for a lot of little things, right? You might have thought you were going to use a, certain voltage regulator, and it's just not available through this supplier. Well, you can find maybe an equivalent that they do carry. But that's a big sourcing issue. Then who's going to make the PCB, right? And how do they work with the supplier? This is one of the reasons why I do like JLC PCB, because they will manufacture the PCBs and they are also a good part supplier with a lot of inventory. And then on top of that, technically the PCB manufacturing and the assembly are separate. And if you're having the parts come from a supplier and then you get the PCBs made somewhere, then both of those have to be sent to the PCB assembly facility. And so with that, who's making this stuff and who do they work with? What suppliers do they have? And so that's all stuff you want to think about, because you don't want to plan out a design and then find out you can't get the parts that you need because of some restriction with who your assembly works with on supply and stuff like that, or how it changes your quotes. Because, pricing will change depending on how much work people have to do to source the components that you want. And so this is stuff you really, if you've never done a PCB before, that can sneak up on you and cause you issues. Now, I was about to move on, but while I'm here, I will say, look, there are some very common PCB fab houses that you'll see a lot on YouTube. I mostly only have experience with JLC PCB, and JLC PCB really is very convenient, I've found, because they are a one-stop shop, right? You can get everything done in one order, right? You put it all in their interface and it is done, and then a few weeks later you get your boards, and they're cheap. So the other ones I haven't used, like PCBWay, has a very good reputation. But, if you want US or European manufacturer, you're going through somebody probably like Osh Park that just does like the PCB, and then you got to find assembly, and that's kind of a pain. But if you're doing assembly yourself, if it's not a complicated board, you might be able to get a hot plate and do it yourself. That might work. Euro circuits, and there are some like Eisler and stuff like that in Europe are available too, but that stuff's going to be more expensive. One of the other things that kind of comes up with that is if you're using JLC PCB or probably PCBWay too, is access to like Asian components, which often save you a lot of money because they're kind of knockoffs of older designs that are, out of patent or whatever. And so that can save you a lot of money to just find a generic part that's much cheaper than maybe a name brand part, but does effectively the same thing. The trade-off there may be documentation. What I've found with a lot of knockoff parts is, as long as you can verify that it's basically the same thing, you can kind of use a data sheet from, maybe ADI or Texas Instruments or something like that. And that can be very handy to get good data. But, sometimes those Asian parts aren't exactly the same. And I have been bitten by that too. But those are just kind of the trade-offs. You can get really nice parts, from, Analog Devices or Texas Instruments, and they work great. You've got great documentation and technical notes and all kinds of stuff, but they come with a price premium. And then you can use a knockoff part, but it may be lacking in documentation, and it may not be functionally exactly identical. I've actually found some that have a little higher spec, but still the documentation's poor. And so you got to make your own trade-offs there. And that is, by the way, while we're here, a very good recommendation if in the part selection phase, Texas Instruments and Analog Devices have such great like white papers and technical documentation. That is a great resource for figuring out how to do stuff and getting layouts and circuit schematic kind of prototype stuff down, because they will give you recommended designs that pretty much just work. And if you read like technical notes, they'll talk about some of the problems and what you might change. And if you're new at this, that's invaluable. I have found a lot of help from their guides on ADC stuff that, thinking of things that I would have never thought of as far as filtering and layout and things like that. So, using their parts to me is some of the benefit for them of, hey, I'm using your documentation, I will use your parts, because it pays, right? That extra money does go to provide that documentation in some respect. So sometimes, especially in small volume, the extra price is kind of worth it, because it's only maybe a couple of dollars when it turns out at the bottom line to add a nicer part. And, in the supplier, in these parts costs and PCB manufacturing costs, assembly is one of the big costs. PCBs are real cheap. Some of the parts aren't really that expensive. That ESP32 module is going to cost you $3 to $5, but assembly might cost you $15 to $20 for that board. So just be aware, like that's where a lot of value is. And so sometimes in a small product run, parts cost aren't the big deal. If you're only making 5 or 10 of something, assembly is where the big money is. Now, if you're making 1,000 or 10,000 or 100,000 or something, all of a sudden the parts get really expensive because, they only drop so much, whereas assembly, once you get it to a certain scale, sometimes the cost will keep going down with volume. Okay, so a quick summary of all the stuff I've been rambling about. First question, do you really need an ESP32 for whatever you're doing? Now, if you need Bluetooth and Wi-Fi, then probably an ESP32 is going to be about the cheapest way to do it. You could do with like a Nordic chip or something. There are some others out there, but ESP32 is really common. Lots of community support online, so maybe a good choice. Next up, do you really need to make your own PCB? Can you just use a dev board, or do you really need to make enough of these to warrant creating a PCB? Or granted, do you just want to do this? Because I mostly do this because I want to in some respect, not really making any money off this. So if you can use a dev board, if you're only making 1 or 2 of something, probably a dev board's a better, more economical choice. But if we're going to make our own PCB, here are the big things. Number one, you have to be very specific about what you need it to do, what sensors, what accessories, what peripherals, what communication protocols that you really need. Then you have to think about the specifics of the parts you're going to be using. Again, specific models and variants of those parts, remembering that there's going to be some trade-offs as you go. You might find cheaper versions, you might find ones with more documentation that really tell you exactly what you need to do that's helpful if you're kind of unsure. But there's going to be trade-offs between, can you get Asian cheap knockoff parts, or are you going to be using the good stuff? It's going to be a price versus probably documentation more than quality thing. Then, if you're driving a certain process, how much horsepower do you really need? How much RAM do you really need? Do you really need a dual core? My broad recommendations are, if you need power, get an ESP32S3. If you don't, you need a single core processor, I would just default to the ESP32C3. If you need something more specific like Zigbee or ultra low power or something else, then you can look through their model line and see if they've got something that's a better fit. But base, the S3 and the C3, those are the two that I would say cover most everything that you really want to do. Next up, once you've got all that kind of laid out, you need to start thinking about your power budget and power delivery. Right? How is the power going to get in? How much do you need? Is it going to be a battery? Is it going to be USB? Do I need a battery management? Do I need a battery charger? Is that going to be handled externally? Those sorts of concerns. Next up, space and layout. How small does it need to be? And does it need to fit in a very specific orientation in an enclosure? Well, that's just something only you know based on what you're wanting to do, but those can affect your design somewhat. It can affect what kind of connectors you can use, where those connectors need to be, may change like how big the board needs to be to fit that stuff, how tall, right? All that stuff. Are you going to get conflicts with, hey, this thing needs to be in that spot and another thing can't be in that spot? Well, that causes your whole layout to shift. So those are going to be things to think about. And then lastly, who's going to be manufacturing the board and where you're going to be getting the parts. And that may put constraints on what parts you can use. And if you haven't already noticed, you don't just go through this linearly. You do your best, and then as you hit a problem, sometimes you have to go back and you have to revise. And you may have to think, well, I thought this was going to work, but as it turns out, this part's no longer available, or they don't have enough. By the way, I didn't mention that before. Whenever you go looking at suppliers for specific parts, make sure they have enough inventory and that it's not just available. Do they have enough of that part? Because they may have 5. And if you're making 10 boards and you need 2 per board, well, 5's not enough, right? So things like that. So yes, sometimes you have to come back through this loop and make some revisions and then update this stuff. But this is kind of the high level, the things you want to be thinking about. So here is what I'm going to try to design to go through this series to show you kind of how I go through that process. So step 1, here is my design. Now I haven't gone through specific parts, so that would come next, but just so you can be aware of where I'm going with this thing, I'm going to design a freezer temperature alarm that integrates into ESP Home. And the reason for that is I actually had a freezer go out earlier in the year, and that was a real problem because I lost a lot of good meat. And so because of that, I don't want that to happen again when I get a new freezer. So, gonna make an alarm. It's gonna be able to send me notifications to my phone. It's gonna run thus over Wi-Fi. And so it's gonna be battery powered for this design. Now, I don't know ultimately if I actually need it to be battery powered. I might be able to put a USB power supply close and just have it plugged in, but I'll design it with battery power just so you'll see, because I figure a lot of battery powered devices may be helpful for people. I'm going to use thermistors for the temperature sensors, and that usually comes in like a 10K or 100K thermistor. I'm going to use at least 2, maybe up to 4. I haven't really settled yet. I definitely need an ambient and I need an inside device, but I might want to put like one at the bottom, one at the middle, one at the top, because typically the bottom is going to be colder than the top, and I might want to check multiple places. I'm going to be using like small jacks, like headphone jacks for plugs, so that's going to be the plug design that I'm going to need to work around. I'm figuring that temperature accuracy is not actually that critical. I mean, honestly, if it's within a couple 3 degrees Celsius, that's plenty, because really I just need to make sure that it's not thawing, right? So the onboard ADCs on ESP32 are probably good enough for this, so I'm not going to have to work in external ADCs. I don't think I'm going to put a display on this thing. I thought about it, but the more I think about it, it's going to be going through ESP Home, so I can always just pull up the temperature on my phone. Yeah, it might be nice to check it when I walk by, but displays suck power, and if it's already on battery, that's already kind of a compromised situation. I don't want the display sucking power. And yeah, I could use an e-ink display, and that doesn't use much power. However, e-ink displays are very expensive for what they are. They require kind of special driver boards, and I don't think I'm going to have this thing update that frequently, and the display would stay static and might fool you into thinking that that is kind of more up to date than it really is, right? Because if I only have this thing updating a few times a day, that display is going to be out of date pretty much very quickly. It's going to be small just because I don't think this is going to take a lot. So maybe 2.5, 3 inches square, but mostly the design is unconstrained from a space kind of perspective. I'm going to be doing a custom 3D printed enclosure, so I can kind of do whatever I want. The orientation stuff, it's just going to be like a square PCB probably. But yeah, not much in the way of constraints there. So that's kind of what I plan on doing. So that is going to be the end of the first video in this series. I think it's probably long enough here. I hope that you found that useful. And by the way, if you have more to add, if you've got more experience in other gotchas you want to drop in the comments for people to see, please feel free to do that. I am not trying to put myself out there as the be-all, end-all. Certainly, my experience with this is way less than a lot of people online in the community. So I'm giving you my best instruction on how I go about this and things that I've learned that can bite you. And most of it you can see is, look, plan ahead. Don't get caught off guard. That's expensive to put in an order, because these things are not going to be cheap whenever we go to order them. And then you find out you waste your money and stuff doesn't boot, like I've had issues with, or you got the wrong parts on something, or a bad orientation. You got to do a bunch of hand rework. I've had to do that too. So we're going to go through this and I'll show you kind of the gotchas and things that I've found. But like I said, feel free to add your comments down below. As always, I really do appreciate your time. Thanks.